Hello and welcome to my kitchen. This is where I did some videos for you using a whiteboard, and here is the whiteboard in question. And before I did the videos, of course, I had to clean off the whiteboard because there's all this stuff on it, but I thought it might be of interest to review what is on this whiteboard because this is where I was doing my planning for the recently worked on unit we did on probability. That is, yeah, teachers actually make concept maps. And so let's just do a little tour of this. Over here on the left, you see some things that everything's written in my nearly illegible handwriting, and so I can read it to you. Here you can see basics, expected value, treasure chest, discuss in breakout, together see strategies. Remember the treasure chest where there was a 50% chance of getting $30 and a 1/3 chance of getting 60 and 1/6 of 300? That's what this is. And then you see roulette question mark. Oh yeah, we talked about roulette. And then this, which you can barely read, says plant growing 1 centimeter sunny, 0 centimeter cloudy, 5, 6 sunny. Expected growth in 30 days? Question mark. Oh, you've seen that. But let's look over here where we have boxes and arrows. Here we see what I think is sort of the basic thing, area model. That's what came from all the other videos from 10 years ago. And you can see that I think this leads to the random walk, which leads to this box, bin sim, which stands for binomial simulator. But back here at random walk, from random walk, we also got the law of large numbers definition of probability. From the binomial simulator, we saw that spread increases as the square root of n, the square root of the number of steps. We also saw an informal confidence interval for proportions if you did the little extension thing where we say, oh, if you're doing a poll and you get 52%, how much above and below that 52% do you really think the true value might be? And this all points to variability, and you could see area model also connects to expected value. And this symbol here is a not equal sign tilted on its side. That is the very important topic I wanted to try to get across, that we can compute expected value, the theoretical value that you would get if everything came out smoothly. But that is not the same as what you will actually get because real life and real uncertainty creates a great deal of variability in the values that you will get. And you need to be able to hold two things in your mind at once, namely that you can calculate this very important thing, the expected value, but also realize that the variability that you will get is going to impact your decision making and everything like that. This arrow goes up to pandemic logistic growth, an activity we probably have not got to yet. And here is this little thing that is talking about expected count in area model. That's where we get to pandemic logistic growth. But it's related to this problem we might do. And what this text says is, legendary Lick teacher cards, collect them all. There's a problem, like suppose there are 6 cards for legendary Lick teachers, and you open up cereal boxes and you get 1 card, and it's random which card you get. How many cereal boxes do you need to open in order to get all 6? And of course it's going to vary because it's random, but how many do you expect to open? Oh, the difference between expected value and variability. Right, that's all there. Down here at the bottom, you see this thing that says, make art, P equals 1/4 that it's good. Oh, remember that problem? There's a 1/4 probability that you get a piece of great art each day, and then probability of good one in 4 tries. Yeah, that's it. And so we're saying we expect to be able to get it, but you won't necessarily. And so this once again has to do with expected value and variability. Over here on the left is an area we haven't done very much. There's this area on conditional probability, which by the time you watch this, maybe we will have discussed. There's a little arrow to Markov, which is a game we definitely will play. And this here is HIV test, which could be a COVID test, but Traditionally, it's the HIV test issue, and the question here with conditional probability is, if you get a positive result on your test, what's the chance that you actually have the disease? And we think of it as 100%, but it's not. And it's very important to understand why not. And this arrow goes to this box, which looks like Bluff or Briars or something, but really it says Bayes, B-A-Y-E-S. This is a very important and alternative way to look at probability, and we will definitely do at least one lesson on that so you know what it's like, what that is, when you finally hear about it. So there's a tour of the whiteboard before it gets erased, and I hope this also serves as a little bit of a review and a means of trying to connect up some of these topics that we've done recently. Thanks. We'll see you in class.